Hey, welcome back AP Calculus students. Today we're looking at the fundamental theorem of calculus part 2. So we're adding a new thing in here, and this is super important for the rest of the class because this is how we calculate our antiderivatives when we're given start and end points. So we can find the exact values for these. It's just saying that the integral from a to b of our function is equal to, and we said the capital F means the antiderivative, right? So if we can find the antiderivative, we just substitute our endpoint and we subtract our antiderivative with our starting point. Okay, so we're gonna introduce the power rule for anti-differentiation. So if we're taking the integral of something that has a power on it, so x to the n, what that's gonna be equal to is x to the n plus 1 divided by n plus 1. Okay, so let's kind of show why this works so it's a little bit easier for you guys to remember. So if we have x cubed, we know that if we find the derivative, we should be able to do that pretty easily now because we spent the whole first semester on doing derivatives, right? So we take our 3 and drop it down, and then we subtract 1 from the exponent, right? So from the fundamental theorem of calculus idea, if we go backwards, right, if we do the antiderivative or the integral, then we should get the exact same thing that we started off with. So let's use the anti-differentiation power rule, right? So it says that we're going to have x to the n plus 1. So this is going to be 2 plus 1 is 3, right? We still have this 3 in front. And then we're going to do we have the 3 in front because it's not part of our x, right? So we're not touching it. We just have to do our antiderivative on the x part. And then we're going to do over n plus 1, which is the same exponent here, right? Over 3. And guess what? The 3's cancel out, and we get back to where we started here. Okay, so the power rule for antidifferentiation is the integral of x to the n is equal to x to the n plus 1 over n plus 1. Okay, so something that you should remember, and we're going to be covering it a bunch. We're going to be doing it over and over again, so it should become second nature, like the power rule for derivatives was. All right, so let's kind of apply this. We're going to evaluate this. We have the integral from -1 to 3 of x cubed plus 1 dx. So the first thing is we're going to do the antiderivative. So remember, we're going to do x to the, well, the n is 3, so we're going to add 1 to that. That's 4 over 4 again. Remember, anytime we have a constant, it's x to the 0, right? 1x to the 0. So then if we were to apply the same power rule to x to the 0, then we have x to the 1 over 1, and that whole thing is just x, right? Another way to think about it is if we derive x, we get 1, right? So the reverse is true. If we anti-derive 1, we get x. Okay, and then we're going to do this, and the notation that we write for this, well, the way I like to write it, it's sometimes written differently, but I like to put these brackets on. And the notation is from 1 to 3, so you get -1 on the bottom and 3 on the top. And that just reminds me that I need to do the f of b minus f of a to find the actual value here. So then if I plug in 3 here, we get 3 to the 4th over 4 plus, don't forget this other x, 3, and then I'm going to subtract. Now be very careful here because we're subtracting that whole thing, so we're going to put it in another bracket. So from, this time we're going to do -1 to the 4th over 4 plus -1. Kind of running out of room here. Let me just change colors. So 3 to the 4th is 3 times 3, 9, 81 over 4 plus 3. Let's just do that as common denominator. So 3 is the same thing as 12 over 4. So we got 81 over 4 plus 12 over 4 minus, and now we're going to do negative 1 to the fourth is positive 1 over 4 plus negative 1 is 4 over 4. It's a negative 4 over 4. So when we go ahead and simplify that, 81 over 4 plus 12 over 4 is 93 over 4 minus 1/4 is 92 over 4, and then minus negative is plus 4 over 4 is 96 over 4. 96 divided by 4 is 24. So this whole thing is 24. Okay, so the next one, this one's really weirded, funky, and you guys got to be really careful when you're doing this because it can be super confusing. But it's telling us to find the area of the region between the curve and the x-axis. Between the curve and x-axis. So what this is saying is we're trying to find the total or the absolute value. So remember we said anything beneath the x-axis is counted as a negative. In this case, they're saying, all right, find it as if it were a positive. It's easy to do when you have a calculator because we don't have to worry about the negative and positive parts. We just say absolute value of. But in this case, because we're doing it manually, we're going to have to do it in two separate parts. So we're going to do it in the first part. This is, let me see. This is the graph of 4 minus x squared. Now, this first part from 0 to 2 is all positive. So we can just take that number. It'll be the number we're looking for. Now, the second part, though, this part is below the x-axis. So we're going to have to make that part positive because it's asking us to find the total area. All right, so let's go ahead and do this. We're just going to set up our integrals. So first thing we want to do is we want to do it from 0 to 2. 4 minus x squared. And then the second part, we're going to actually do the absolute value. I'm just going to write it in. It's not going to make a big difference as long as you remember to make it a positive at the end, either way. This time we're going to go from 2 to 3, right? Because we're looking in this interval there of the same function. Okay, so let's go ahead and find our antiderivative using our power rule. So we're going to take this in parts. So we're going to go from, well, 4x minus x cubed over 3 from 0 to 2. And then we're going to add the second part. But the second part, because it's below, again, we're going to have to make sure that it comes out positive. So we're going to go from, we already found the antiderivative from 2 to 3. Okay, so let's plug this in. So 4 times 2 minus 2 to the third, which is 8 over 3. So it's going to be 4 times 2 is 8 minus 2 to the third is 8/3 minus, right, because we got to plug in our 0 now. So 4 times 0 is 0 minus 0. Okay, so minus 0. That comes out nice. Okay, so the second part now, we're looking at this. We're going to do the same thing from 2 to 3. So we already found out what 2 is, right? This is if we plug in 2. And then when we plug in, 3. 3 is our start. So when we plug in our 3, 4 times 3 is 12. 3 to the third is 27 over 3. And then minus R2, which we already found, right? So that's going to be 8 minus 8/3. So the cool thing is that we have that minus that is 0. So we just have to do 27/3 plus 12. So 27/3 plus 12 is going to be, oh wait, Wait a minute. Wait a minute. I shouldn't do that. This is the absolute value, right? So let's find this first, because I think that makes a difference. Okay, so let's find this whole value here. 12 over 3 is, 12 in thirds is 36 thirds plus 27 thirds is 36 plus 27 is 63. No, yeah, 63 thirds. Yeah, I should have just simplified that from the beginning. So 63 thirds, that's fine. 8 as a third is 24 thirds minus 8 thirds is 8 thirds. Wait, 16 thirds. I'm screwing this up. 16 thirds. 24 minus 8 is 16 thirds. So this is going to come out to be the absolute value. Let me just check here just to make sure we got it correct. 16 thirds plus 63 thirds minus 16 thirds should give us 23 thirds. Did I do something wrong? 16 thirds. Okay, I know we got this part correct. 4 times 3 is 12. Oh, this should be a minus. That's what I did wrong. Sorry about that. Whoops. This is a minus. Okay, so actually, um, 12 in thirds is 36 thirds minus 27 thirds is 9 thirds, right? 9 thirds. So this whole part here is going to be negative 7 thirds, but we're taking the absolute value. So we have 16 thirds. This whole thing is 7 thirds negative, but we're doing the absolute value of, right? So then 16 thirds plus 7 thirds is 23 thirds. Yeah, be very careful and don't be silly like me and put the wrong sign in there, and you should be good. Okay, the last one, this one's super easy because we're using fn. So find the area between the curve and x-axis and y equals x cosine 2x over the interval negative 3 is less than or equal to x is less than or equal to 3 using fn int. So remember, we're going to do math 9 to get to our integral. We're going to fill in our integral. We're going to put our starting point negative 3. We're going to put our ending point 3. And we're going to put in x cosine 2x. But then because it's saying, again, between the curve and x-axis, this means the total, which also means absolute value. All right, so you have to absolute value that thing and dx. So to get to absolute value, again, you have to do math. You're going to shift 1 over to the right using that arrow key, and then it should be your first one, ABS. Okay, so if we input this into the calculator, we should get what was it? I just did it earlier, 5.43. And it took my calculator a little bit of time to think, so don't think that it's breaking. It's just kind of like calculating. So you should end up with approximately 5.43. Okay, that's it for today. Sorry for the hiccup on the second to the last problem. I gotta be more careful with my calculations and my signs. But good job today.